Envision an enormous ensemble played by an endless number of stars, planets, and moons, all playing together wonderfully. Anyway, there is one specific segment of this symphony that has astounded space experts for quite a long time: exoplanets. Exoplanets are regular planets that exist outside our planetary system, stowed away somewhere down in the Milky Way. You may be astounded to discover that, among the tremendous number of astronomical objects, there are exoplanets so like Earth, so tantalizingly similar, yet confounding that they very well may be our planet's celestial twin. We dive into the intriguing domain of Proxima B, found simply 4.2 light-years away. The James Webb Space Telescope is upsetting our quest for an understanding of these divine mysteries. Envision a moment when your mind ventures across the tremendous cosmic domain of our world, the Milky Way, which is home to in excess of a quadrillion exoplanets. That's a number with 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, but we would have enough to make another landmark on Earth, a Grand Canyon 2.0 that would stretch for a significant distance. What is most astounding is that around 20% of these heavenly bodies have been designated Earth-like in terms of topography and air structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our moon, caught in gravitational dance with their parent planets. If you were to think about finding another body in space that harbors life, or could do so, the universe offers an overflow of opportunities. Now that we have unfurled the material of inestimable scale, it's time to present the expert craftsman, ready to paint its complex subtleties, the James Webb Space Telescope. This divine Sherlock Holmes, with its magnified focal lens supplanted by adjustable focal points, beats even the most advanced optical instruments. We're not talking about any lens. It's 6.5 meters in primary mirrors, 2.7 times bigger than Hubble's. Envision the best detail it can distinguish, even in the slightest flash of a star billions of light-years away, and then, at that, examine the subtleties of circling planets. What makes the James Webb Telescope revolutionary isn't just its noticing power, but also its high-level technology, including advanced sensors and spectrographs. These tools can do much more than just observe. They can analyze and filter the extraordinary light marks transmitted or reflected by heavenly objects to interpret their air conditions, piece density, and even mass. Acting as a space scientist, they can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the capacity to answer these questions, elevating it from a mere eyewitness to a scientific virtuoso. It's not just an advance over its predecessor, Hubble, it's more like a quantum leap. If Hubble's discoveries amazed you, prepare for a real gala of heavenly disclosures. Just as we expanded our look across the intricate landscape of the universe, it's worth focusing on one specific star in the celestial show, Proxima B. Since its discovery in 2016, this puzzling planet has stood out as a Shakespearean hero, filled with intricacy and conundrums, dazzling stargazers and anthropologists alike. What's going on with all the fuss? First of all, Proxima B is essentially in our astronomical neighborhood, just 4.2 light-years from Earth. To place it in context, if you could beat the universal speed limit and go at the speed of light, you would arrive in a little more than 4 years, about the same amount of time it takes for your favorite program to fall into reruns. But let's dig further into why this proximity is so significant. We're discussing a universe that extends more than 93 billion light-years from one end to another, so tracking down a planet so close and so encouraging for scientific research is like finding a jewel in a pile the size of Mount Everest, a jewel that possibly holds secrets about life itself. In the grand tapestry of the universe, Proxima B is a multifaceted line offering us important clues that could redefine how we understand habitability and life beyond Earth. It's not just Proxima B's proximity to Earth that excites established researchers, but also the enticing signs that this planet is not only Earth-like but potentially Earth 2.0. Proxima B sits comfortably in what space experts call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, wandering waterways, immense lakes, and maybe even seas as deep and mysterious as the Mariana Trench. But before we start dreaming about traveling on Proxima B, let's consider a few of its quirks. First off, a single day on this fascinating exoplanet lasts a staggering 11 days. Envision dawns that not only usher in a new day but unfold slowly, resisting giving way to noontime, and sunsets that linger, making brilliant hours that photographers long for. While it sounds idyllic, it also has significant implications for its atmosphere and habitability. How might human biorhythms adjust to the patterns of light and dark on Proxima B? Would we really need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this totally different world? The basic patterns of life, as far as we know them, would be at once tantalizingly similar and frustratingly strange. It is as if nature is presenting us with an enigma, wrapped in a puzzle, testing our understanding of what makes a planet habitable. You might wonder how we can gather accurate and reliable data about a world we've never visited. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only observe planets but examine them through a prism of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. The space forensics, not just cosmology, it's space criminology. We don't sit idly waiting for clues to come to us. We actively seek them, investigating the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky, but a highly specialized research lab, investigator, and cosmic detective all in one. It allows us to turn our theories and speculations about alien worlds into strategies to confirm or deny them, revolutionizing our understanding of what might exist beyond our blue dot. Just when you thought you had uncovered the most shocking layers of this astronomical onion, the story takes an unexpected turn. Much like in any sci-fi thriller, scientists using the James Webb Space Telescope caught something remarkable from Proxima B, a signal so surprising that it spread throughout the academic hallways and social media. Named as a potential technosignature, it was an electromagnetic emission so complex and intricately designed that it could point to the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the peak of a discovery that promised to reshape our view of reality. Could the signal be the historical proof that we are not alone in the universe? And just as quickly as it appeared, the signal vanished without repeating itself, leaving behind not only an overwhelming silence but also a labyrinth of unanswered questions and bubbling theories. Was it simply a transient celestial anomaly, a coincidence of cosmic alignment, or something more intentional, a coded message, or even a sign of an extraterrestrial intelligence? The lone mission cast a shadow of mystery over Proxima B, igniting fierce discussion and speculation. Was it merely a passing oddity? Or is it part of a much larger story, more complex than we can imagine? But wait, the story of our cosmic exploration isn't complete. The ink has not yet dried, and new chapters are still being written. This time, it's not just traditional researchers, but Harvard scientists who are leading a shift in perspective in our search for extraterrestrial life. They are not content with merely investigating the signal and phenomena we've discussed so far. They are raising the stakes by turning the James Webb Space Telescope into a kind of giant night vision telescope. They aim to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're talking about staggering possibilities, such as the chance of detecting earthly versions of cities glowing in the dark, like bright SPS. Imagine seeing the glowing beams of what could be a city, humming with the presence of an advanced civilization, radiating its warmth into the vast cosmic seas. As we continue to unravel the mysteries of the universe, the journey for extraterrestrial life takes on new dimensions. Beyond the immediate interest in Proxima B, our grand search digs deeper into the immense, unfamiliar regions of space. This pursuit is driven by both technological advancements and a profound curiosity about our place in the universe. Ongoing breakthroughs in cosmology and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to identify and study these distant worlds. One particularly intriguing area of study is the search for biosignatures, indicators of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could suggest biological processes. The JWST's capabilities extend beyond simple detection. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable precision. By studying starlight that filters through an exoplanet's atmosphere, scientists can detect chemical markers indicative of life. For example, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could point to the potential for life-sustaining conditions. Another avenue of investigation involves studying the environments of these distant worlds. Climate models based on data from the JWST can help predict whether an exoplanet's conditions could support liquid water. This is crucial because water is considered a fundamental element for life as we know it. Scientists are particularly interested in planets located in the habitable zone of their parent stars, where temperatures might allow stable liquid water. The search also extends to the moons of exoplanets. Some of these moons, especially those in the habitable zones of their host planets, might have conditions conducive to life. For example, icy moons in our own solar system, like Europa and Enceladus, are thought to harbor subsurface oceans beneath their icy crusts. Similarly, moons orbiting exoplanets could present analogous conditions where life might exist. Moreover, the concept of technosignatures has gained traction. These are signs of advanced civilizations that may be detectable through artificial structures or technologies. This could include megastructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our global collaborations and observational techniques, the search for technosignatures could uncover the presence of extraterrestrial intelligence. In addition to technological advances, international cooperation plays a critical role in the search for extraterrestrial life. Collaborations between space agencies, research institutions, and private companies enhance our ability to explore space. For example, missions to Mars and other celestial bodies involve contributions from multiple nations pooling resources and expertise to achieve common goals. Public engagement and education are also vital components of this mission. The excitement surrounding space exploration inspires the next generation of scientists and engineers. Effort programs and educational initiatives help foster an interest in STEM fields and encourage young people to pursue careers in space science. The development of new technologies also contributes to our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and analyze distant exoplanets. For example, next-generation space telescopes like the planned Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HabEx, are poised to offer even more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, every new discovery raises new questions and areas for exploration. The search for extraterrestrial life isn't just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our perception and expands our understanding of what it means to be alive. In conclusion, the exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each advancement, we edge closer to answering some of the most profound questions humanity has ever asked. As we continue to explore the universe, the possibilities for finding new forms of life and understanding our place in the cosmos remain limitless.